Welcome back to Remarkable. In today's video, we're diving into linear inequalities, a topic that looks similar to linear equations but has a few extra steps. We'll start by learning how to solve linear inequalities algebraically, and then we'll move on to graphing them on the coordinate plane and shading the required region. By the end of this video, you'll know exactly how to handle any linear inequality question with confidence. So let's get started and make this topic easy and remarkable. Now, to indicate the relative size of two quantities or expressions, we have three symbols that refer to equality. So we have this equal to sign. I'm sure all of us are aware of this, but just a quick recap to ensure that we are absolutely sure of what these signs mean. This means not equal to. And then we have this sign, which means approximately equal to. Okay. We also have four symbols that refer to inequality. What are those symbols? So let's just substitute values. So for example, we have y is less than a. So this means, what does this mean? It means that y is less than a. What does this inequality mean? It means y is less than or equal to b. Okay, so why this change? Because now we have this equals to under the inequality sign. Okay, so this is a strict inequality. A is not included. Y is less than A. Strict inequality. In the second one, we have an equals to below the inequality, which means that y is less than or equal to b. So b is included in the answer. Okay, I hope this is clear. Okay, the third one is y is greater than c. And then the last one, that y is greater than or equal to c. So let's change this to d. Okay? So inequalities, these are the four inequality signs that you need to be aware of. One simple way or a trick basically to remember how or where you should place your inequality is to visualize this inequality as an alligator mouth. Okay, so the alligator is always going to eat the bigger number, always. So for example, if we have 5 and -2, what is the bigger number? 5. So the alligator is going to eat the bigger number. Okay, so if you have any confusions in placing the less than or greater than sign, just always remember this trick of alligator mouth, that the alligator will always eat the bigger number. Okay, so a is obviously greater than y because the alligator is eating a up. So y is less than a. Here y is greater than c. Why? Because the alligator is eating y up. Okay. Now inequalities, before I move on with explaining how we can represent inequalities on a number line, I want to tell you that, an equation, basically it shows that one side is equal to the other side. So for example, 4x plus 3 is equals to 2. So one side of the equation is equal to the other side of the equation, and it is separated by an equal sign. An inequality can show that one side is different from the other side of the inequality. So for example, 4x plus 3 is greater than 2. Okay, so an inequality, it looks like an equation. However, the equal sign is replaced by one of the inequality signs. It can be any one of these, right? And the rules for solving inequalities are the same as rules used for solving equations. Exactly the same. What you do on one side of the equation is what you have to do on the other side as well, okay? However, when solving inequalities, there's one extra rule that you need to keep in mind. The rule is that whenever you multiply a negative quantity or number, the sign of the inequality changes. Okay, we'll get into the detail of this in a bit. First, let's learn how to represent inequalities on a number line. Okay, so this is the number line. Okay, and we have 0, 1, 2, 3, 4, 5, 6, 7. Okay, so an endpoint that is included is marked with a filled or solid circle. Okay, an endpoint that is not included is marked with a hollow or empty circle. Now, for example, if they ask you to represent z is greater than or equal to -2 and less than 3. Okay, so let's plot this on the number line. First, we have to see that -2 is included. Okay, so we have an inclusive inequality here. So what kind of circle are we going to have? We're going to have a filled circle. Okay, so this is for inclusive inequality, while hollow circles are for strict inequalities. What is a strict inequality? One that does not have an equals to sign. So z is strictly less than 3. 3 is not included in the range. Okay, so z is greater than or equal to -2. So -2 is included in our answer range. And then 3. 3 is a strict inequality. So we will have a hollow circle here. Okay. So this is your inequality. What are the numbers that are in this region? -2, since the circle is colored, filled in. -2, -2, -1, 0, 1, 2, and 3 is not included. So these are the integer values which satisfy this inequality. Okay, let's do another example. Okay, so if we ask you to show the range x is greater than or equal to 1 and less than 6 on a number line. Okay, now what you need to note here is that the 1 itself is included in the range. We have an equals to, so 1 is included in the range, and this will be shown by a filled in or a solid circle, right? So the endpoint of this will be colored, a solid circle. And the 6 is not included in the range, and this is shown by an open or hollow circle. Okay, now let's just plot it on the line. Okay, so 1 is included, hollow circle, and we'll go up till 6, but 6 is not included, so a hollow circle. 1 will have a solid circle, the endpoint will be solid, and for a strict inequality where we do not have an equals to sign with the inequality, we will draw a hollow circle. Okay? Okay, now for example, if they ask us to show x is greater than 1 and x is less than -1. Okay, so how are you going to show this on the number line? Okay. Okay, the first thing to note is that these are strict inequalities, so hollow circles. Okay, so x is greater than 1. Hollow circle, the values of x, they're greater than 1. Now let's have a look at the second part of the inequality. X is less than -1. Again, strict inequality, so hollow circle, and all the values of x that we can have are less than -1. Okay, so this is how you're going to represent it on a number line. Here, the only thing that you need to keep in mind is that hollow circles are for strict inequalities, while solid circles are for inclusive inequalities. Okay, now let's see how we can algebraically solve linear inequalities. Solving inequalities. Okay, as already stated, an inequality looks like an equation with one of the four symbols: less than, greater than, less than or equal to, greater than or equal to. Okay, one of these is going to be used in place of an equals to sign. When solving inequalities, the rules are the same as for solving equations. Okay, so do to the left hand side what you do to the right hand side of the inequality. But there's one additional rule which is of extreme importance, and you need to keep that in mind whenever you're solving an inequality, that if we multiply or divide by a negative number, we must reverse or flip the inequality sign. I will explain this in a minute. Okay, so for example, we have this inequality that 9 is less than 11. Okay, now we multiply this inequality by -1. Okay, so let's multiply by -1. So what do we have? -9 and -11. Now, as per this rule, we need to flip the inequality because we've multiplied with a negative number. And see, if Had we not changed the inequality, we would have gotten this, which is not true. The alligator is eating negative 11 even though it is smaller than negative 9. So the alligator mouth is always going to eat the bigger number. Negative 9 is bigger than negative 11, right? So this is a rule that you need to incorporate every time you're solving an inequalities question, okay? Let's have a look at another example. So 9 is less than 12, okay? So now we divide, let's say that we divide by negative 3. Okay, because we're dividing by a negative number, the inequality should flip. So when we divide by negative 3, divide by negative 3, what do you get? You get negative 3 and negative 4. The inequality sign flipped. And rightly so, because negative 3 is bigger than negative 4. So the alligator mouth is going to eat the bigger number. Let's do a couple of examples and hopefully this will make more sense. So see, solve 15 minus 2x, which is greater than 21. Okay, so just like we solve equations, what are we going to do? I will take this negative 2x to the other side because generally I like dealing with positive numbers. And I will take this 21 to the left hand side. Okay, so I have 15 minus 21 greater than 2x. 15 minus 21 is negative 6 is greater than 2x. We're going to take this 2 to the other side and we are going to divide it. So what do we get? We get negative 3 is greater than x. Okay, this is the solution to our equation. Okay, had I solved it the other way around, okay, where I would take 15 to the other side. Okay, so what do I have then? Negative 2x is greater than 21 minus 15. Negative 2x is greater than 6. Now, notice what we're going to do. To find the value of x or to segregate x, we need to divide by negative 2. So we will take this negative 2 to the other side. So what are we doing here? We are dividing by a negative number. So the inequality sign needs to flip. Okay? And we will have negative 3 as the answer. So whenever you divide by a negative number, the inequality sign flips. Here, because I took 2x to the other side and made it positive, even though we have the same answer. So the alligator mouth is eating negative 3. So we have the same answer, whatever route you follow, but you need to remember that if you divide by a negative sign or multiply by a negative sign, the inequality will flip. Okay? Okay, let's do another question. So solve the inequality minus 3x is less than or equal to 2x plus 14. Okay, so what are we going to do? Just like we would in an equation, we're going to bring all the x's to one side and the numbers to one side. Okay, so minus 2x minus 3x is greater than or equal to 14 minus 4. So what have I done? I've taken this 2x to the other side, so it becomes negative 2x, and the 4 has been taken to the right hand side. So this is plus 4, it is negative 4 here. Okay, negative 2x, negative 3x will be negative 5x less than or equal to 10. Now what is going to happen? We are going to divide by a negative number. So what is the inequality sign going to do? It's going to flip. So x is greater than or equal to -2. Sorry, -5. -2. Okay. Okay, so it's pretty straightforward and simple. The only additional rule that you need to remember is that the if you multiply or divide by a negative number, you need to flip the inequality. Okay? Okay, another thing that they might test you on is a double inequality. Now, what is a double inequality? So, for example, they ask you to solve this inequality. So, what do we have? We have a double inequality sign in a single question. Now, there are two ways to go about solving this. One, you can solve them simultaneously. So, whatever you do here, you perform the same actions on both the sides of the inequalities. However, I always tell my students to break the inequalities, and in the end, when we get the final answers, we can combine them together. Okay, so what is the first part of inequality? This is the first part of the inequality. So we're going to write it separately. Okay, so -5 is less than 3x plus 4. Now, what is the second part of the inequality? It is this. Okay, so we are breaking our inequality into two. So first we're going to forget this part and we're just going to jot this inequality down. And then for the second part, we're going to forget this part and jot this inequality down. So it's going to be 3x plus 4 less than or equal to x plus 7. Okay, now you can just solve these two inequalities in the same way that we've learned how to solve these simple inequalities. Okay, so let's start. -5 minus 4 is less than 3x. -9 is less than 3x. -3 is less than x. Okay, so this is the solution to the first part of the equation. Now let's get on to the second one. All the x's to one side, constants to the other one, so 2x. 3x is less than or equal to 3/2. Okay, so basically the question was that we need to find the integer values of x which satisfy this inequality. So find the integer values of x that satisfy this inequality. Okay, so what did we get? We've solved both the parts of the inequality separately. Let's plot whatever we found in the answer. So x, strict inequality, the first thing that you need to notice. So we are going to have a hollow circle here. So x is greater than -3. Okay, so -3 is not included and x is greater than. So all the values of x are greater than. So it is going to be on this side. Okay. Basically this side. Okay. The second part of the inequality. So x is less than or equal to 3/2, which basically means 1.5. Okay. And this is an inclusive inequality. So what are we going to do? At 1.5, we're going to draw a solid circle. Okay. And x is less than or equal to 1.5. So basically, this is the value or the inequality for the second part. So the purple part is this result on our number line, and the green one represents this solution. Okay, now which part overlaps? So basically, this is your solution, right? So what are the integers? -3 is not included, -2, -1, 0, and 1, as indicated by the arrows, okay? And what is your inequality if we combine it together? What is it going to be? So it's going to be x is greater than -3 but less than or equal to 1.5. So this is your solution algebraically, and if we plot it on a number line, this is how we're going to plot it on a number line. So you do not necessarily need to draw the number line to list the integer values. You can also figure that out from this equation. So -3 is not included. It will have -2, -1, 0, 1. And since it's less than or equal to 1.5, that is where we're going to stop. Okay? So I don't think you can get a very technical question about solving linear inequalities. आपको इसी तरह कुछ इसी का कोई variant test करेंगे, okay? So even if you have a double inequality, it's very simple to break it into two and then solve them separately and then combine the answers. Now on to the final part of the topic, graphical representation of inequalities. A lot of students struggle with this part of the topic, but I find it pretty simple. Let's hope that by the end of this video, you are of the same opinion, okay? So a number line can be used to show the solutions to an inequality that involves one set of values, right? But when we have inequalities with two sets of values, say x and y, we can show the solutions together on a pair of numbered x's, one for x-axis and one for y-axis. Okay, so let's discuss a couple of examples to understand what I mean. Okay, so this is our numbered okay, I will just copy this for future so we will save time. Okay. Okay, so for example, okay, here I would suggest that you have a look at the coordinate geometry video, or if you need to make sure that the coordinate geometry concepts are clear here, because sometimes the problem is not with inequalities, uh, but it is with the fact that you're not very confident about finding the equation of lines. Okay, so finding the equations of lines and straight lines, recognizing them, sketching them, all of this should be absolutely clear before you tackle this part of inequalities, okay? So in case you have any confusions regarding that, please make sure that you go and watch the video on coordinate geometry. Okay, so for example, we have a straight line at this point. Okay, so assuming that your coordinate geometry is strong and you can identify the equation of this line. So the equation of a vertical line is always in the form x is equals to a constant. In this case, that constant is x is equals to 4. Okay. Now, if we have the inequality x is greater than 4, okay, so which region represents the required region on our graph? Okay, so this is the line x is equals to 4. So whenever you're given an inequality and you need to show it on the graph, you should first plot the line and replace the inequality sign with the equals to sign. Okay? Once you've done that, then you need to figure out what is the required region. Okay? So basically there is a wanted region and an unwanted region. When the straight line x is equals to 4 is drawn on a graph, all the points to the right of the line satisfy the inequality x is greater than 4, right? Because see 5 and then it's going to be 6, 7, 8. So all of these regions, they all of the points to the right of the line satisfy the inequality x is greater than 4. What about the area to the left? The area to the left of the line x is equals to 4 is basically the unwanted region. Okay? So as a tip, I'm going to tell you that until and unless it has been specified clearly in the question, you are always going to shade the unwanted region. Okay, always do that. So now let's see. X is greater than 4. Which region is that? It is to the right of the line. So what are we going to do? We are going to shade the left side completely, the unwanted region. We will always shade the unwanted region. Unwanted. Okay? And had your inequality been x is less than 4. Okay, so wait. Okay, so this is the line, x is equals to 4. And if the inequality was that x is less than 4. So x is less than 4c. So 3, 2, 1. Which region is that? Towards the left of the line. X is equals to 4. Okay. So this region is the wanted region. Which region are we going to shade? We always shade the unwanted region. So what region is that going to be? The region to the left of the line, to the right of the line, x is equals to 4. Okay, so what is the rule that we can derive? So the rule is that if the inequality, this is for vertical lines, okay? It is different for horizontal and slanted lines. For vertical lines, what is the rule? That if the inequality is greater than, so for example, is x is greater than, okay? So which region is wanted? The region to the right of the line is wanted, okay? Then the unwanted region, let's just write wanted. The wanted region is on the right, and if the inequality is x is less than, wanted region is on the left. Okay, If the inequality is less than, the wanted region is on the left. And we are always going to shade the unwanted region. Okay, so for example, let's very quickly put this rule to test. Okay, so let's draw two lines. Okay, and a second one here. So what are the equations of the line? This is x is equals to, x is equals to 1, and this is x is equals to 6, right? Now let's shade it, and we will try and figure out. So basically the region on the left is shaded, on the right, and the left of x is equals to 1 is shaded. Okay, and they're asking you to list down the inequalities which represent the unshaded region. Okay, as per our rules, this is the line x is equals to 1, right? This is the line x is equals to 1, and the wanted region, basically this unshaded region is the wanted region, right? इस लाइन के कहाँ पे हमने शेड किया हुआ है? लेफ्ट पे. The region wanted is on the right. So if the region wanted is on the right, what is the inequality? It is greater than. Okay, so this is going to be x is greater than 1. Now let's have a look at the second line. This is x is equals to 6. The wanted region is on the left of the line. So when the wanted region is on the left, we always put a less than sign. Okay, so in this case, x is less than 6. And it does make sense otherwise as well. All these numbers, they're greater than 1. All these numbers, they're less than 6. Okay, so basically, the region representing the required inequality is left unshaded. Any point x, y, this is an important point. You need to understand that any point x, y within this unshaded region is a solution to the inequality. Okay, so any point in this region, any coordinate set of coordinates, they would satisfy these inequalities. And it is not just for this specific question, for any shading inequality question. Okay, so I first tackled the vertical lines. If the wanted region is on the right, your inequality will be greater than. If the wanted region is on the left, your inequality will be less than. Okay, so you need to memorize that. If the wanted region is on the right side, right of the line, then the inequality is going to, the sign is going to be greater than. And if it's on the required region is on the left, the inequality is going to be less than. Okay, now let's tackle horizontal or slant lines. So the rules for them are, let's first jot down the rules for them and then we'll apply them. Okay, so as a general rule, if the inequality reads y is greater than or equal to then wanted region is above the line. Okay? And if the inequality reads y is less than or equal to, then the unwanted region, the wanted region is below the line. Okay? Let's so just remember, before I explain any question, so see, if you have this line and this line and this line, okay? Now, if whatever the equation is, so if it's y is less than whatever the equation is, we'll get to that in a bit. Since you have a less than sign, the wanted region is below the line, okay? So if you have a less than or equal to sign, then the required or wanted region is below the line. So what region are you going to shade? The unwanted region is going to be above the line, okay? Similarly, if this is y is greater than whatever, okay, greater than means the region above the line is wanted. So which region are we going to shade? We're going to shade the region below the line, the unwanted region, the region that we do not want. Okay? And the final inequality, so this is a vertical line, so the rules are going to be different. So if x is less than 5, it's 5. If it's less than, what is the required region? The one which is on the left. Less than for a vertical line means the region on the left is the required region. So what are we going to do? We're going to shade the region on the right. So basically, what is the required region? This unshaded region is the required region. Okay? Let's practice a proper example to make sure that you understand. But before I get into the example, there's something that I should have stated earlier, but I forgot. So just like strict inequalities are represented by hollow circles and inclusive inequalities are represented by colored circles on a number line, in case of when we're plotting inequalities on the graph, strict inequalities are represented by dashed lines. Okay, always remember that, broken or dashed line, while inclusive inequalities are represented by solid lines. Never forget that. It has been clearly specified in your syllabus now. Initially, there was no distinction between the two, but now they've clearly mentioned that broken lines are going to represent strict inequalities, while solid lines will represent inclusive inequalities. So make sure that you also take care of it. Okay? Okay, so let's tackle this question. The question is asking you to list the inequalities that represent the unshaded region. Okay, now what is the unshaded region? This is the unshaded region. So the first thing that you're going to do is that you're going to count the number of inequalities that basically, or the number of lines that bound the wanted region. So 1, 2, 3, and 4. Okay, so there are 4 lines No, actually not this one, because the region, so 1, 2, and this is the third one, 3. Okay, had this been shaded as well, then there would have been 4 lines. So 1, 2, 3, 4, if this was shaded. But since this is not shaded, we have 1, 2, and 3 lines. Okay, so basically you need 3 equations. Or the first step towards listing inequalities or finding the shaded region, the first step is always that you're going to find the equations of the lines. If they're not mentioned in this question, they are mentioned, and then you're going to label the lines with their equations. Okay, once you've done that, now let's tackle one equation at a time. Okay, so y is equals to 4. The wanted region is below the line, right? The wanted region, the unshaded region is below the line. So basically line ke kahan hoga? If the wanted region is below the line, it's always less than. Okay, so you're going to write this as less than 4. And why is it a strict inequality? Because this is a broken line. So x is equals to 6 will not be included in the, sorry. Okay, sorry. We're looking at y is equals to 4. This is a solid line, so it is going to be an inclusive inequality. Okay, so y is less than or equal to 4. Again, because the required region is below the line, we will have a less than inequality, less than or equal to. Okay, now let's have a look at this broken slant line. The required region is above the line. So what are we going to do? We are going to have a greater than sign. Okay, because the required region is above the line. If it is above the line, what is it going to be? It's going to be greater than. And because it is a broken line, it will be a strict inequality. We're now going to put an equals to with the inequality. Now let's have a look at the third line, which is a vertical line. So we have different set of rules for vertical line. If the required region is on the right, we will put a greater than sign. If it's on the left, we are going to put a less than sign. Now x is equals to 6. This is the line, and the wanted region is on the left. So what is it going to be? It's going to be less than. And because it is a broken line, strict inequality. So x is less than 6. So what are the 3 inequalities which satisfy the triangular region that satisfies the 3 inequalities is represented by these 3 inequalities. Okay, so the trick here is just to remember that if it's a horizontal or slant line, if the required region is above the line, then it's greater than. If the required region is below the line, it's less than. Okay, and for vertical lines, if the required region is on the right, it's greater than. If it's on the left, it's less than. If you memorize these rules, I don't think you can have or you can face any problems in placing the inequality signs. Here the inequalities were given, they were drawn on the graph. Now they might just list the inequalities and ask you to draw them on the graph and figure out what the required region is. So this is a question. Draw a graph to show the region R which contains the points satisfying all of the following inequalities. Okay, so I hope all of you are aware of how you're going to plot a straight line graph. Okay, so first you're going to just forget about the inequalities. Assume this is y is equals to 1. Y is equals to 1 is going to be a horizontal graph, right? Y is equals to constant is always a horizontal graph. Next we have y minus x is equals to 2. Let's make y the subject. Y is equals to x plus 2. How do we plot this on the graph now? as I've mentioned a lot of times, you're going to quickly draw a table and take random x values. I always used to take -1, 0, 1 as a student, but you can choose any values that you want. Okay, so if, and the same goes for the third equation. 2y plus x is equals to 10. 2y is equals to -x plus 10. Y is equals to, okay. Okay, so we have the three equations. Let's learn how to plot them on the graph. Okay, so the first line is very straightforward. Y is equals to 1, a horizontal line which crosses y at 1. Okay, so this is line. And you also have to label the line. Y is equals to 1. Okay, so the first one is done. Let's have a look at the second one. So the second equation is y is equals to x plus 2. As I said, we are going to quickly choose values. So if you substitute -1 in place of x, what do you get? -1 plus 2. The answer is 1. If you substitute 0, you get 2. And if you substitute 1 in place of x, you get 3. Okay, so let's plot these points on the graph. -1, 1. -1, 1 is this. 0, 2. This point. And 1, 3. This point. So you basically just need 2 points to plot a straight line, but we just choose 3 to, make sure that we are on the right track. So this is what your equation will look like. Okay, so how do you plot a line, a linear equation, which is given to you? You're going to construct a table very quickly and take random x values, put those x values in the equation and find the respective y values, and then you will have 3 points. So -1, 1, 0, 2, 1, 3. You plot them on the graph and then you just join them together and extend your line. After that, you're going to label your straight line with the equation x plus 2. Okay, now we're left with the third line, which is okay, y is equals to -x plus 10 over 2. Okay, so we're going to draw the table quickly once again. Okay, now the points that I'm going to take are going to be such that I have an even number in the numerator, because I wanted to be completely divided by 2. Okay, so even if I take -1, 1, -1, 0, 1, whatever points I'm going to get points in decimals, and if I plot them, I'm going to get the correct line. But to make my life easy, I will choose -2, 0, 2. Okay, so if I substitute -2 in place of x, what do I get? 12 divided by 2, so I get a 6. If I substitute x is equals to 0, I get a 5. And if I substitute x is equals to 2 here, -2 plus 10 is plus 8 divided by 2, it's 4. Okay, so now I have 3 points. What are the 3 points? -2, 6. So -2, 6 is going to be this point. 0, 5, this point. 0.24, this point. Okay, let's plot the line. Okay, and let's label it with the equation. Y is equals to negative x plus 10 divided by 2. Okay, so now we've plotted all the three equations or the lines on the graph. Now what we need to do is to shade regions such that they satisfy these inequalities. So let's copy them. And since we are done with, I hope that, plotting straight lines is not a problem for anyone here. Okay. So first line, y is equals to 1, and the inequality says that y is greater than or equal to 1. Okay, so greater than or equal to 1 means what is the wanted region? The wanted region is above the line. And we are going to shade the unwanted region. And so unwanted region is below this line. Okay, so we're going to shade the unwanted region. Okay, and we're also going to change this equals to sign with the inequality sign. So greater than or equal to. When it's greater than or equal to, the required region is above the line. So we have shaded the unwanted region, which is below the line. Okay, next is this. So this is going to be y is less than x plus 2. Okay, so it is less than strict inequality. So the first thing that we're going to do is that we're going to break this line. Okay, because it is a strict inequality, it does not include basically the points on the line are not included. Okay, second step, the inequality is less than, y is less than, so the required region is going to be below the line, right? Since it is less than, the required region is going to be below the line, so we're going to shade the region which is above the line. So the region which is above the line is shaded. Okay, last equation. So 2y is less than or equal to 10 minus x. Y is less than or equal to 10 minus x over 2. So what is the inequality? It's less than or equal to, right? Less than means the required region is below the line. So this is the line and the required region is below the line, and since it's an inclusive inequality, the line will be solid. So which region are we going to shade? What is the unwanted region? The region above the line is unwanted. Okay, so we're going to shade the region above the line as unwanted. So what is region R? This is region R. This, the wanted region, the unshaded region is this. So I hope that this is clear. All you have to know is that if it's a horizontal and slant line, and if you have a greater than inequality, then the required region is above the line. If it's a less than inequality, then the required region is below the line. And for vertical lines, if the required region is on the right, then it's greater than. If it's on the left, then it's less than. Okay, let's do this past paper question. This is also slightly different. Why? Because here they've drawn the lines on the graph and they've given you the inequalities separately, but they've not specified which line represents which equation. Okay, so the first step here is that you're going to label all the lines on your graph. Okay, let's start with the easier ones. This is x is equals to 3, x is equals to 2. Okay, this is y is equals to 2x plus 1. This is y is equals to 4 minus x. Okay, now assuming that you have full knowledge of coordinate geometry and you know that your vertical lines are always in the form x is equals to a constant. So this line is going to be x is equals to 3. This is going to be x is equals to 2. So let's first label these. So x is equals to 3. Okay. So x is equals to 3, x is equals to 2. Okay, next. Now let's have a look at the third line. We know that slant lines are in the form y is equals to mx plus c. So m is the gradient, which is 2 in this case, and the intercept is 1. What is the y-intercept? The point where your line crosses the y-axis, okay? So which line is crossing the y-axis at 1? This one, okay? So we know that this is represented by this equation is represented by this line. Okay, so we are going to label this as y is equals to 2x plus 1. And obviously then the fourth line, the left line would be the fourth equation. But you can also figure this out by the fact that this has a negative gradient. The coefficient of x is negative, so we will have a downward sloping line, and also the intercept is 4, so this line is crossing the y-axis at 4. Okay, so now you have successfully labeled all the lines on the graph. That is always the first step towards solving the equations. Okay, now let's place the inequalities. So x is less than or equal to 3. Okay, so what is the required region? Since it is a vertical line and the inequality is less than or equal to 3, it means the required region is on the left. So what are we going to do? We're going to shade the region which is on the right, the unwanted region. Okay, so we're just going to shade the unwanted region. Okay, next is x is greater than or equal to 2. Since it's greater than the line, this is the line and it's greater than, so the required region will be on the right of the line, right? So the unwanted region is on the left, so we are going to shade the unwanted region which is on the left of this line. Okay, done. Now let's come to the third line. Y is less than or equal to 2x plus 1. It is a slant line. Less than means we need the region below the line. Okay, since it's less than, so the region below the line is the required region. What are we going to shade? We are going to shade the region which is above the line because that is our unwanted region. Okay? Okay. The final line. Y is greater than or equal to 4. Okay, since all the inequalities are inclusive, the lines are also solid for all 4 inequalities. Okay, so greater than or equal to, greater than means the region above the line is the one that we want, or the required region. So we are going to shade the region below the line completely. Okay, So now let's have a look at the region which is required. Which is the required region? So see, this is the required region, the one which is left unshaded. Okay? So if you tackle this question, the questions from this topic of inequality in this way where you follow the rules for slant and horizontal lines, if it's greater than, the region above the line is required. If it's less than, then the region below the line is required. For vertical lines, if it's greater than, then the region on the right is the required region. If it's less than, then the region on the left is the required region. We always shade the unwanted region until and unless it has been specified to do otherwise in the question. Also, whenever you're shading or labeling, make sure that you do it with a very light hand, okay, so that in case you need to erase something, your work doesn't get messy. Once you're sure of your answer, then if you want, you can darken your pencil. Okay, this is also a past paper question. This is another way that they can test you on inequalities. So here they've given you the lines, they've shown you what the required region is. So this is the required region, and they've asked you to write down 3 inequalities that define the region are. So 1, 2, and 3, these 3 inequalities. However, no equation has been given to you. So using coordinate geometry, we are going to first find the equation of these 3 equations, and then later we are going to figure out the inequality signs. Okay, so let's begin with the easier one. A vertical line is always in the form y is equals to a constant. That constant is this value, so let's figure out what this value is. So since this is 1, this is going to be 1.5. So the line is y is equals to 1.5. Okay, the first inequality. Now let's figure out this second inequality. So the other 2 lines are slanting line, which means the equation is going to be in the form y is equals to mx plus c. So we need to find the gradient and the intercept. The intercept for both the lines is very clear. So for this line, c is 1. For this line, c is 1. And for the dotted line, c is 4. So let's first focus on this line. So we know that c is 1. We need to figure out m. What is the formula for calculating the gradient? M is the gradient, right? y2 minus y1 over x2 minus x1. So what are we going to do? We have this line. We are just going to choose any 2 points on the line. So we can choose this point, 0 and 1, and we can choose this point, 1 and 3. So what are the 2 points? 0 and 1, 1 and 3. Let's find the gradient. It's going to be 3 minus 1 over 1 minus 0, 2. So the gradient of this line is 2 and c is 1. So what is the equation going to be? It's going to be y is equals to 2x plus 1. Okay? And now similarly for the broken line or the dashed line, c for this, now we are going to figure out the equation for this line. C is 4. Okay? Let's find the gradient. Let's choose any 2 points. So I'm going to choose 0, 4 and 4, 0. Easy points. 0, 4 and 4, 0. So what is the gradient? The gradient is going to be 0 minus 4 over 4 minus 0. So it's going to be minus 4 over 4 for minus 1. Okay. So the equation is going to be y is equals to m is negative 1. So negative x plus 4. So now we've evaluated the equations of all 3 lines. So each line is now labeled with an equation. Now we are going to place the inequality signs. So let's begin with the horizontal line. So the required region is above the line, right? So it is going to be greater than or equal to, because it is a solid line. Okay, so what is the inequality going to be? Greater than or equal to. So the first inequality is y is greater than or equal to 1.5. Okay, now let's have a look at this line. So this is the line and the region is below the line, right? The required region is below the line, so it's going to be less than. Since the required region is below the line, the inequality sign is going to be less than. So y is less than or equal to 2x plus 1. Okay, now on to the final broken line. This is the broken line and the required region is below the line. So it is going to be less than. Strictly less than because the line is broken. Okay, so y is less than minus x plus 4. Okay, so I hope this question is clear, and this basically brings us to the end of this lesson on linear inequalities. Remember, you can be tested in different ways. You might be given the inequalities and asked to draw and label the lines and then shade the correct region. Or you could be given the graph where you'll need to figure out the equations of the lines, just like this example, and write the correct inequalities based on the shaded region given in the question. In some cases, you may even be given just the lines and you will have to write the inequalities they represent and shade the region accordingly. Whichever way the question comes, just follow the steps we covered and you'll be good to go. If this helped, don't forget to like, subscribe, and share, and I'll see you in the next one, right here on Remathable.